inspiring, and we are grateful for the knowledge you have shared with us today. Next, I request our Pro-Chancellor, Dr. Syed Nadeem Akhtar Sir, to address the audience. He has been instrumental in fostering a culture of excellence and innovation at our university. His strategic initiatives and forward-thinking approach have significantly contributed to our institution's growth and development. Sir is a Fulbright Nehru Fellow and serves as the Pro-Chancellor at Integral University, Lucknow, India. He holds a PhD in Mechanical Engineering from the Indian Institute of Technology, Kanpur, and both his undergraduate and postgraduate degrees from IIT Kanpur. Sir's dedication to academic excellence is complemented by his commitment to creating a supportive and inclusive environment for both faculty and students. Under his leadership, the university has seen the implementation of numerous programs aimed at enhancing research capabilities, promoting interdisciplinary collaboration, and encouraging the pursuit of knowledge. His leadership has also led to the university securing a NAC A+ grade, advancing internationalization, and enhancing ICT-enabled education. Please join me in welcoming Dr. Syed Nadeem Akhtar Sir.
Thank you, Dr. Afreen. Our chief guest, Shri Syed Feroz Adil Naqvi Sahab, the Deputy Director General, National Informatics Center, Government of India. Our guest of honor, Professor Karmveer Arya, Professor and Head Department of Computer Science, IITM Gwalior, who is also my senior from college. Professor Balasubramaniam Raman, Professor and Head Department of CSE, IIT Roorkee. Professor Aqil Ahmed, the Advisor to Honorable Chancellor. Professor Abdul Aziz, the Dean, Faculty of Engineering, here at Integral University. Distinguished colleagues, Deans of Faculty, Heads of the Departments, my dear students, ladies and gentlemen, a very good morning to all of you, and Assalamu alaikum wa rahmatullahi wa barakatuh. I warmly welcome all the distinguished guests and my esteemed colleagues and the bright minds gathered here today. And it is an honor for me to stand before you at this conference that is dedicated to advancements in science, engineering, and technology. We are here to celebrate the remarkable strides we have made, exploring promising new frontiers and forge connections that will drive future innovations. Ladies and gentlemen, in recent years, the pace of technological advancement has been nothing short of extraordinary. One of the most significant developments has been in the realm of artificial intelligence, and we have heard almost all our esteemed guests speak about AI. AI is transforming scientific research, enabling breakthroughs at unprecedented speeds. From predicting protein structures with, for example, DeepMind's AlphaFold, to discovering new antibiotics and advanced materials, AI is reshaping our approach to scientific discovery. And when we talk of AI, some of the other buzzwords that were mentioned by our chief guest were machine learning, data analytics, etc. Now, presuming that most of the audience here is having a background in computer science, we all might have gathered some knowledge about neural networks, machine learning, training of the minds. Here in our mechanical engineering workshop, we did a wonderful experiment about how the neural networks are trained. And this experiment was on natural neural networks, which is our brain. So what we observed was that, in fact, we tried to observe how a child learns to ride a bicycle. And for a child of an appropriate age, let's say 4 to 5 years old or maybe 6 years old, it takes about 3 to 4 days to learn how to ride a bike. It is not about strength. It is not about any technique or so. It is all about forming the right neural network, forming the right neural connections in the brain. So the child has to know that when the bicycle is about to fall to the left, he or she has to turn left. And when the bicycle is about to fall to the right, he or she has to turn towards the right. That is all he has to learn, which takes 3 4 days, and the child learns how to ride the bicycle. So what we did was we built a bicycle which, if you turn the handle to the right, the wheel turns to the left, and vice versa. Now, this is a very beautiful study because for people like almost all of us who know how to ride a bike, it is impossible for us to ride this modified one. It is absolutely impossible because we are not trained, our connections are not formed to ride such a machine. But if we bring a 5 years old who doesn't know how to ride a bike and give him this bicycle, he will learn it in 3 4 days because he would think it's a normal, that's how things are supposed to work. If you turn right, the bike is supposed to turn left. Okay. Now suppose we try to learn this modified bike, learn how to ride this modified bike. First we have to unlearn and break all the pre-existing neural connections in the brain. Then we'll have to form new connections which will help us ride this bike, new bike. Once we know how to ride this modified bike, we will not be able to ride the normal bikes. Right? So that is the detailed thing about forming the neural networks, forming the neural connections. And this is in a way, in a very layman sort of way, about machine learning. So in our daily lives, whatever we are trying to perform with our hands and limbs is somewhere related to our learnings that we incorporate throughout our lives. I would invite you to go and take a chance at riding that bike and get back to me as to were you able to do it or not. In fact, I had a very good money making idea out of this bicycle. You see, we all in this day of cryptocurrency, social media, etc., we all want to make quick money, and I am no exception. So I thought that whenever we have a fair, let's say fiesta, we would charge 100 rupees for the people to ride the bike for 10 meters. And if they are able to do it, we'll pay them 500 rupees. And I can bet that they can't even pedal one cycle. Within a meter, they are going to fall, and the 100 rupees will keep on coming. Okay. Anyways, another exciting frontier is quantum technology, where the recent progress in developing the spin qubits for quantum computing promises to revolutionize the data processing and secure communication. This leap brings us closer to realizing the immense potential of quantum computers. Additionally, integrated sensing and communication systems, ISAC, are making our wireless networks smarter and more efficient, with applications ranging from smart agriculture to urban planning. Coming to the field of engineering, we are seeing advancements in material science which are particularly noteworthy. Innovations like bioinks for 3D printing of organs and the development of new sustainable materials are opening up possibilities for healthcare and environmental conservation. The Artemis program of NASA, that aims to establish a sustainable human presence on the moon, is another monumental step. So this not only advances space exploration, but also drives developments in robotics, space medicine, and material science. We are also witnessing groundbreaking advancements in biotechnology. The CRISPR technology is finally showing therapeutic promise, which is revolutionizing the treatment of genetic disorders and cancer. Innovations like AI-driven diagnostics and personalized medicine are improving patient outcomes and transforming healthcare delivery. Talking of AI-driven diagnostics, we here at Integral University, especially our Department of Computer Science and Engineering, has been continuously working on studying the MRI images of brain to detect brain tumor by using AI. This project has been going on in collaboration with DAD. And I was reading yesterday that using artificial intelligence to uh, to study and analyze mammograms can help identify breast cancer 4 years before it develops. So that is how minutely and in what detailed manner an AI can analyze an image with very, very small spots on the mammogram, which perhaps human eye is unable to recognize so early in the phase of cancer development. Nanotechnology is another field that is seeing rapid advancements. We have new techniques in nanofabrication and development of nanomaterials, which lead to significant improvements in fields ranging from energy storage to environmental monitoring. So we are using gold nanoparticles today in cancer therapy and silicon dioxide coatings in nano devices, which are few examples of how the capabilities of these machines are getting enhanced. Ladies and gentlemen, our conference today is a beacon for students and faculty alike. It offers a unique opportunity to immerse in the latest research, engage with pioneering thinkers, and envision the future landscape of science and technology. For students, it is a platform to showcase their ingenuity, gain insights from experts, and network with potential mentors and collaborators. For faculty, it provides a venue to exchange ideas, initiate collaborations, and stay at the forefront of their respective fields. I extend my heartfelt congratulations to the organizers, Department of Computer Applications, the head of the department, the dean of the faculty, for their dedication and hard work in bringing this conference to life. I am told that between today and tomorrow, we have about 300 presentations scheduled across 8 different tracks, which is quite a lot of information being shared and exchanged. Their efforts have provided us with an invaluable platform to share knowledge, inspire innovation, and drive progress. In conclusion, as we delve into the sessions and discussions ahead, I encourage each of you to embrace the spirit of curiosity and collaboration. Let us harness the collective expertise in this hall to push the boundaries of what is possible in science, engineering, and technology. Together, we can create a future where these advancements benefit all of humanity. Thank you very much for your patient hearing, and I wish you all a productive and inspiring conference. Thank you again.
Thank you, sir, for your inspiring words. Your pioneering work and dedication to advancing the frontiers of knowledge are truly enlightening. We are truly and deeply grateful for your presence and the contributions you have made to both the academic and professional communities. Now, we will proceed with the presentation of mementos to our esteemed guests and dignitaries as a token of our gratitude and appreciation for their valuable contributions and presence today. First, I request Honorable Pro-Chancellor Dr. Syed Nadeem Akhtar sir to present a university memento to our chief guest, Mr. Syed Firoz Ali Naqvi sir. Please join me in giving a big round of applause. Thank you, sir. Next, I request Advisor to Chancellor, Professor Akil Ahmed sir, to present a university memento to our guest of honor, Professor Karamveer Arya sir. Let's show our appreciation with a huge round of applause. Thank you, sir. Now, I would like to request our head of the department and organizing chair of the conference, Professor Mohammad Faisal, sir, to present the conference mementos to our dignitaries. Sir will now present mementos to our Pro-Chancellor and Honorable Dr. Syed Nadeem Akhtar, sir. Let's show our appreciation with a huge round of applause. Next, our chief guest, Mr. Syed Feroz Ali Naqvi, sir. Next, our guest of honor, Professor Karamveer Arya, sir. Next, our Dean, Professor Abdul Aziz Kader Hamsa, sir. Next, our advisor to Chancellor, Professor Akil Ahmed, sir. Thank you, Faisal, sir, and thanks to all our distinguished guests for your presence and contributions. Your participation has greatly enriched this conference, and we are deeply appreciative of your time and insights. As we draw this inaugural session to a close, I invite Professor Mohammad Faisal, sir, head of the Department of Computer Science, Computer Applications, and a key member of the organizing committee of the conference, to deliver the vote of thanks. Sir has been an integral part of the planning and execution of this conference, ensuring its smooth operation. His leadership and organization skills, dedication, meticulous planning, and unwavering commitment have been pivotal in coordinating the various aspects of the conference. Please join me in welcoming Faisal sir to express our collective gratitude to all those who have contributed to this conference.
Thank you, Afreen. Good morning, everyone. As we draw to the close of inaugural session of this remarkable International Conference of Advances in Science, Engineering and Technology, I, Dr. Mohammad Faisal, Head Department of Computer Application and Organizing Chairman for this conference, wish to extend a vote of thanks to all the respected dignitaries, revered guests, participants, and students. First and foremost, I would like to extend my sincere gratitude to our Honorable Founder and Chancellor, Professor Syed Wasim Akhtar Sahab, whose vision and leadership has been the cornerstone of this institution. Sir, your unwavering support and commitment to excellence in science, engineering, and technology have provided us the foundation to organize such a wonderful event. Your guidance has always inspired us to strive for greater heights. Most importantly, I extend our deepest gratitude to Chief Guest, Shri Syed Feroz Adil Naqvi Sahab. Sir, your presence and words of wisdom have greatly enhanced the significance of this event. Your inspirational address have provided us with valuable insights and has set a positive tone for the conference sessions. We are truly honored and grateful for your time and efforts. As a special note of thanks to Honorable Pro-Chancellor Dr. Syed Nadeem Akhtar sir for sharing with us his vision and education to match the best in the world. Sir, your dedication to fostering a culture of innovation and research excellence has been a driving force behind all of our achievements. You have always encouraged and inspired us to work in the direction of creating knowledgeable individuals guiding the university to achieve the prestigious status of NAC A+. I would like also extend a heartfelt thanks to Honorable Vice Chancellor Professor Javed Masarrat Sahab. Sir's continuous support, leadership, and commitment to academic excellence have been pivotal in the success of this conference and the ongoing growth of this institution. Thank you, sir, for your valuable guidance and encouragement. I would like to express our sincere thanks to Professor Akil Ahmed Sahab, advisor to the Honorable Chancellor, for his guidance, support, and strategic advice. A special note of gratitude goes to our guest of honor, Professor Karamveer Arya, Professor and Head Department of Computer Science and Engineering, Atal Bihari Vajpayee Indian Institute of Information Technology and Management, Gwalior. Your presence and insightful contribution have added great value to our event. We are deeply honored to have had you with us, and your participation has significantly enriched our discussion. Thank you, sir, for your valuable time and efforts. A special note of thanks to a special guest, Professor Bala Subramaniam Brahman, Professor and Head Department of CSE, Indian Institute of Information Technology, Roorkee, for his virtual presence. Your thoughts have inspired us truly. I express my heartfelt gratitude to our executive directors, Sayyid Fauzan Akhtar Saab, Sayyid Adnan Akhtar Saab, Registrar Haris Siddiqui Saab, Controller Examination Professor Abdul Rahman Saab, Director HRDC Professor Sayyid Akhil Saab, Professor Abdul Aziz Qadir Hamza, Dean Faculty of Engineering, other deans, directors, and head of the departments for their support, encouragement, and our guidance. We are also deeply grateful to our sponsors, Uttar Pradesh Council of Science and Technology and CRC Press. Your generous support has been instrumental in making this conference possible. Thank you for believing in our vision and for your unwavering commitment to fostering achievement in science, engineering, and technology. I express my heartfelt gratitude to our distinguished keynote speakers, session chairs, and presenters for your presence and participation. A special thanks to our national and international participants who have traveled from far and wide. We appreciate your presence. I would like to extend our appreciation to the organizing committee and all the members of the Department of Computer Application and volunteers. Your hard work, meticulous planning, and tireless effort behind the scenes have ensured the smooth running of this conference. Finally, to our attendees, thank you for your active engagements, questions, and contribution. Your enthusiasm and commitment to learning and collaboration are what make events like this truly meaningful. Let us carry forward the knowledge, connection, and collaboration that we will build in the next upcoming sessions of the conference. Together, we can continue to push the boundaries of science, engineering, and technology for creating a brighter and more innovative future. Thank you.
Thank you, sir, for the heartfelt vote of thanks. Your words truly express our collective gratitude to everyone who has contributed to the success of organizing this conference. As we conclude this inaugural session of the International Conference on Advances in Science, Engineering, and Technology, I would like to take a moment to reflect on the importance of our gathering. This conference brings together some of the brightest minds and most innovative thinkers in our fields. It serves as a platform for exchanging groundbreaking ideas, fostering collaborative research, and inspiring the next generation of scientists, engineers, and technologists. Our heartfelt gratitude goes to our esteemed Pro-Chancellor, Chief Guest, Guest of Honor, and Advisor to Chancellor, Dean, for the presence and valuable insights. Your leadership and dedication continue to inspire us all to strive for excellence and innovation in our respective fields. Over the next 2 days, we will engage in various sessions covering a wide range of topics, including keynote speeches, invited talks, technical presentations, and networking opportunities. Our keynote speakers are renowned experts who will share their groundbreaking research and insights, leading to in-depth discussions and learning. It is our hope that each of you will find these sessions not only informative, but also inspiring, and they will spark new ideas and collaborations. Our technical presentations will feature a series of carefully selected papers that showcase innovative research across multiple disciplines. These presentations will provide an excellent opportunity for research to present their findings, receive constructive feedback, and engage in stimulating discussion with their peers. In addition to the formal sessions, there is an ample room for networking opportunities. Such opportunities are intended to foster collaboration and encourage the exchange of ideas among participants from different backgrounds and areas of expertise. We are now adjourned for a short break, and I request the dignitaries to join us for a high tea. I request the dignitaries and faculty members to join us for the high tea. And we will reconvene in 15 minutes for the keynote lectures and invited talks. Now, as we part for the short break, let us carry with us the inspiring words of Galileo Galilei. All truths are easy to understand once they are discovered. The point is to discover them. Let this thought inspire us as we embark on the journey of discovery and knowledge. Let us remember that each question we ask, each problem we solve, and each idea we share brings us one step closer to uncovering those incredible things waiting to be known. Thank you, everyone. Yes, sir. Ladies and gentlemen, please rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request all the dignitaries to gather in front of the central auditorium for a group photograph, please. Thank you. Welcome back, everyone. Now we are ready to commence with our keynote lecture and invited talks. First, we have a keynote lecture on artificial intelligence applications in traffic engineering by Dr. Mehmet Ali Silgu from Barton University, Turkey. He will be joining online. Dr. Silgu is renowned for his innovative research in AI and its transformative applications in traffic engineering. Dr. Silgu is an assistant professor in the transportation division. His research encompasses traffic flow theory, intelligent transportation systems, traffic management and its applications, safety and logistics. He is an active member of the IEEE Intelligent Transportation System Society and the IEEE Vehicular Technology Society. Additionally, Dr. Silgu is involved with the Turing interest groups on bridging machine learning and behavioral models, environment and sustainability, and simulation-based science. Please join me in welcoming Dr. Mehmet Ali Silgu.
Hello everyone, I am Mehmet Ali Silgu from Turkey. I am an assistant professor in Bartın University, Civil Engineering Department, Transportation Division, and postdoc researcher at Koç University Industrial Engineering Department. My research subjects are traffic engineering, intelligent transportation systems, and smart logistics application. I would like to thank Integral University for giving me the opportunity to delivering my talk for International Conference on Advances in Science, Engineering and Technology 2024, taking place in Integral University, India. My fellow researcher, Mr. Sadat, who is working as assistant professor in the Department of Civil Engineering, had insisted me to attend the conference physically, but due to some personal problems, some health problems, I am unable to attend the conference, and I am sending my presentation in online mode. Let's talk about my presentation. I will start with some very basic reminders before the introduction. As you know that artificial intelligence simulates human intelligence in machines. If we divide into artificial intelligence into two pieces, one of them is machine learning and the other one is deep learning. While the machine learning is algorithms that learn from the data, deep learning is subset of machine learning using the neural networks with many layers. So today I will talk about AI applications in traffic domain with the subsections of traffic flow management, incident detection and management, public transportation, infrastructure management, traveler information systems, environmental impacts, case studies, and real-world implementations. After that, I will go on with future trends, challenge, and consideration. Lastly, I will finish with my conclusion. I hope you will enjoy. Let's start with a question. How AI revolution is in traffic engineering by providing advanced tools and methods for managing transportation systems? The integration of AI technologies can lead to more efficient, safe, and sustainable traffic solutions. So let's go on with the other question. What are the benefits of AI in traffic engineering? Improved efficiency in traffic flow, enhanced safety through quick incident detection and response, and increased sustainability by optimizing the traffic to reduce emissions. Now, let's take a look at traffic flow management. AI algorithms analyze historical data to predict future conditions. These predictions can help in planning and managing traffic flow more effectively. For example, predictive models using machine learning can forecast traffic congestion and suggest preventive measures. The other one is adaptive traffic signals. AI-driven traffic signals adjust their timing in real time based on current traffic conditions. This adaptive approach reduces delays and enhances traffic efficiency. If you want to extend this part with an example, traffic signals that use AI to adapt to real-time traffic data can significantly reduce waiting times at the intersections. Moving on to the next point, in incident detection and management. In traffic engineering, an incident refers to any event or occurrence that disrupts the normal flow of traffic on a roadway. These events can vary in nature and severity, but generally result in delays, congestion, and sometimes hazards for road users. So let's talk about the automatic incident detection and route optimization. They can be counted the AI applications about the incident detection and management. AI systems use data from cameras, sensors, and social media to quickly detect traffic incidents. This rapid detection allows for faster response and minimize the impact on traffic flow. For example, AI can analyze video feeds to identify accidents or breakdowns and alert authorities immediately. For the route optimization, during incidents, AI can suggest alternative routes to drivers and emergency responders, reducing delays and improving overall traffic management. Also, navigation apps using AI can provide real-time route adjustment based on the current traffic conditions and incidents. Next, I would like to talk about and discuss public transportation. In here, we should talk about the demand prediction and autonomous vehicles. AI can forecast the demand for public transportation services by analyzing historical usage data and current trends. This helps in better scheduling and resource allocation. For example, predictive models can help transit authorities adjust bus schedules based on the expected passenger loss. Autonomous vehicles, in fact, AI is crucial in developing autonomous public transport systems such as self-driving buses and the shuttles. This system can reduce operational costs and improve safety. In addition, autonomous shuttles equipped with AI navigate through predefined routes, offering efficient and safe transportation. Now, let's take a look at infrastructure management. Predictive maintenance and smart traffic monitoring can be divided into two parts as an infrastructure management. In predictive maintenance, AI can predict when infrastructure components such as roads and bridges will require maintenance. This proactive approach prevents costly repairs and enhances safety. AI models can analyze the data from the sensors and forecast the degradation of the road surface and schedule timely maintenance. For the smart traffic monitoring, AI-powered cameras and sensors continuously monitor traffic conditions, detect violations, and provide data for infrastructure planning. Smart cameras can identify traffic rule violations and send data to authorities for enforcement and planning. So, if we talk about the traveler information system, in fact, it is personalized travel assistance and multimodal transportation. Now let's talk about the environmental impacts. We can tell in this part emission reduction and electric vehicle management have significant roles in this part. AI optimized traffic flow to reduce idle times and emissions, contributing to greener urban environments. AI-driven traffic management systems can reduce the congestion, leading to lower vehicle emissions. For the electrical vehicle management, AI manages the deployment and the charging of electric vehicles to maximize the efficiency and minimize environmental impact. AI algorithms optimize the location and operation of electric vehicles charging stations based on the demand patterns. If we talk about the case studies and real-world implementations, in fact, there are two really good examples about that. One of them is Los Angeles, the other one is Singapore. In Los Angeles, AI-powered adaptive traffic signals have reduced travel times and improved traffic flow significantly. For the Singapore, AI-driven public transportation systems have optimized bus schedules and routes, enhancing commuter experiences. Now, let's have a look to future trends. Integration of AI with IoT and AI with vehicle-to-X communication seem the future trends of AI in traffic. Smart cities with interconnected infrastructure and IoT devices providing continuous data for AI analysis will be good examples for the integration of AI with IoT. In AI and vehicle to X communication section, vehicle to everything technology enables communication between vehicles and infrastructure, and AI enhanced vehicle to X predicting and managing traffic scenarios dynamically. So if we talk about the challenges and considerations, data privacy and security, and the ethical and regulatory issues are the challenges and considerations. For example, large-scale data collection raises privacy concerns and importance of secure data handling and anonymization techniques. For ethical and regulatory issues, AI decision making must be transparent and fair, and the regulatory frameworks needed to ensure safety and accountability. And with the technology, please remember that we have to work on continuous innovation and collaboration. AI is revolutionizing traffic management through real-time monitoring and predictive analytics, autonomous vehicles, and smart traffic signals. Future trends include deeper integration with IoT and vehicle-to-X communication. Data privacy, security, and the ethical considerations is crucial. With this, I would like to conclude my talk. I would like to thank Chief Patron Honorable Chancellor Prof. Basim Akhtar, Patron Honorable Pro-Chancellor Professor Nadim Akhtar, and Honorable Vice Chancellor Professor Javid Musarat for such opportunity.
If you want to ask any question, please do ask. Any questions, students?
Thank you, Dr. Silgu, for your insightful and thought-provoking lecture. Your expertise in traffic engineering and intelligent transportation systems has provided us with valuable knowledge.
Thank
I
you.
don't think that anybody is raising hand for their question. Thank you, sir, for joining us.
You're welcome.
Next, we have an invited talk on application of deep learning models for change detection using Sentinel-1 images by Dr. Mohammad Siddiq from Marjan University College, Oman. Dr. Siddiq's work in deep learning and remote sensing has made significant contribution to the field. Sir is a senior fellow of Advanced HE UK and currently serves as the head of registry at Marjan University College. With over 20 years of academic and industrial experience across the Sultanate of Oman, South Korea, and India, he has taught various IT subjects to both masters and undergraduate students in reputed universities and colleges. In addition to his academic roles, Dr. Siddiq has served as a director of studies and program manager. He has coordinated and developed numerous large-scale real-time applications in IT companies, utilizing the latest technologies on Microsoft and Java platforms. His research interests include image processing, artificial intelligence, data science, and distributed and parallel computing. Please join me in welcoming Dr. Mohammad Siddiq with a huge round of applause.
Thank you very much. It's my honor and privilege to be here as a keynote speaker. Thank you to the organizers for such a wonderful conference, and I'm happy to be part of it. As you can see on the screen, today I'm going to talk about application of deep learning models for change detection using Sentinel-1 satellite images. So if I have to start with my outline, I'm going to talk about the introduction to the satellite images itself, especially Sentinel images. And then I will emphasize more on the coherent change detection techniques and deep learning based forecasting, which is prediction of the data, implementation of change detection techniques, change analysis and forecasting, and then validation processes of the outcomes that is achieved through the processes and recommendations. Right. First of all, we need to understand what is change detection. Now, change detection is a technique in which we try to gather images, satellite imagery from different times, and then try to find out the difference between them so we could understand the changes in the patterns or features through observations. And for that, we will work on the images. Now, what are the satellite images? Satellite imagery is available as a data from Copernicus Data Hub. There are many different platforms from where you can get it, especially from the European Space Agency satellite images are easy to access. I'll talk about the importance of change detection. So before you start working on the change detection techniques to identify the patterns or changes, you need to pre-process these images. And then you can generate different images from different times to understand the change patterns. And after that, you can have a post-image classification to get into the statistics and accuracy details accordingly. There are two different ways or methods I would emphasize on change detection techniques. One is coherent change detection. It's a traditional change detection technique in which, like I said, you have images of different times and try to understand the patterns by implementing some of the algorithms, such as, for example, OTSU algorithm, and then you identify the patterns, and then you work on that through some machine learning or deep learning techniques. Deep learning networks are require more labeled data based on the number of parameters. So the number of parameters will be also discussed in this session. So like I said, first of all, we need to understand what is this data, how we can utilize this data. From the Copernicus Open Access Hub, it is satellites. They have a lot of satellites in European space agencies, which are observing the Earth. They are orbiting the Earth and they are observing. And then they also provide some of the services and tools such as Sentinel-1A, Sentinel-2, and different satellite imageries. I am particularly focusing on Sentinel-1 images because they are quite useful in identifying the change patterns on areas such as agricultural fields or let's say rivers, river basins, and even, for example, if it is weather conditions. Sentinel data can be accessed from Copernicus data space ecosystem. This is a link, which is freely available data. And for processing these images, you can implement the change detection techniques and deep learning techniques by using some of the applications which I have mentioned here. For example, Snap Desktop. This is a Sentinel's application platform available for you to download. It is free of cost. NV Classic is another platform for image processing. QGIS Desktop, Google Earth Pro, and Google Colab for writing deep learning algorithms or implementing models, ensemble models, and so on. Now, these satellite Sentinel-1A images are very beneficial because they can help us in identifying the change patterns. For example, if I can choose a case study of a flood management, because that is one of the area which I have researched a lot. So in understanding or assessing the change patterns of the flood, they are very much useful. And you can always gather images before the crisis happens or during the crisis or after the crisis. And you can
compare and look at the results according. So these sentinel images are in GRD products, and it has very clear distinction between different land covers like water, urban, vegetation, and bare soil regions. So based on the region of interest where you are searching the data or analyzing the data, you can process those images and analyze it. Satellite images can also be used to monitor distinction between different land covers. Not only the changes, but also the distinction between those different land covers. Now, based on recent studies, what I gather, some of the important areas or research gaps where more research could be done are working on change detection techniques by acquiring large data patterns. For example, data sets of 5 years or 10 years, and then working on those by processing those images, because Sentinel-1 images work in both day and night at all weather conditions, and they are very compatible. This change detection can also be performed to get accurate statistics, accuracy details, error rates, and compare the statistics and come up with outcomes, and that supports the concerned authorities, for example, to take required actions. So in the context of, let's say, flood maps, if you could look, then the flood maps can be prepared and analyzed through these processes, through implementation of these change detection techniques, and that can help these authorities to take required action. A sample coherent change detection techniques can reveal the changes in the pattern. For example, if you see, this is a sample Sentinel-1 image of city of Ayodhya. In 3 different perspectives, a subset of those images have to be created, and then you can try to understand the pattern changes. So during, for example, rains, heavy rains or floods, you will know the changes in this pattern. Like you can see the red, dark red patches over the city and river basin, and it is affecting a vegetation area. And the other subsets are giving you a clear distinction of what was the actual pattern before the crisis or during the crisis or after the crisis. So this is just a RGB composite of those images initially can be prepared. Further, the image differencing can be created. This is just a technique by following, let's say, Otsu algorithm. You identify the difference between images of 2 different times. And then you can also compare this particular pattern with 2 other images of different times, and then identify those changes. We always refer to them as stacks, stack 1 and stack 2. So for example, stack 1 would be images of before the crisis that has happened or during the crisis, and stack 2 could be part of images during the crisis and after the crisis. So it gives us a clear information on how these changes have happened and what was the actual area and what has been the affected region. Further, this is again a stack overlay of segmented images. So segmentation of images are very important for clearly distinguishing the regions of interest. So you can see the red patterns, red patches on these maps shows that these are the places where there was more of water logging. So a lot of water logging areas were there. Now, a sample change detection statistics are here. So during change detection techniques, which is a coherent change detection technique, you identify this pattern. It also gives you the statistics, such as the mean values between both the stacks or coefficient variation, standard deviation, and threshold positive and negative. Now, what is threshold positive? Threshold positive are the ranges which gives you an indication that there have been a positive impact. For example, there have been more waterlogged areas, more inundation in an area which was inhabited earlier, but now it is covered with water. But if you look at threshold negative, so it is below the threshold, and then it is nothing has been affected and everything looks fine. So this is an early indication of the data, which gives you an idea. So to define these finest segmentations, this can be auto-registered. These images have to be auto-registered. Maybe you're not fully aware, but if you can start using these applications like Snap, you will have an understanding. how you can co-register image and identify the changes or patterns. The computation, for example, to identify the image differencing here is based on time 2, for example, on time 1 images and that are close to each other, very closer before or during the crisis and so on. And the formula is there, which is also formula threshold, which is equal to mean plus or minus or plus or negative 2 into standard deviation. So based on the statistics, you can identify the threshold and you will get to know the details of that. Now, deep learning, a lot of our dignitaries and speaker have already given you an idea of what is a deep learning. So I don't want to go into basic definitions here, but deep learning, like for example, CNN model or naive forecast are some of the important models that can be implemented on the different images that you have designed already and identify the data further. Now, deep learning, as you know, are to be implemented through applications. For example, you can use Keras API in TensorFlow. You can use Pandas for data analysis using Python language, or you can use NumPy, which is Python library for numerical data, and you can use these real models. Now, like our earlier colleagues said, to understand and implement machine learning or deep learning technologies or methods, you need to train the data sets. So you always need to have a windowing and horizon segregation of the data. You need to have a training and test data based on which these models work. So you need to have the data sets of multiple years of data, like 5 years or 10 years or more, and then NumPy indexing to understand these windows sets, and then understand the test and training sets. One of a proposed model which I had worked earlier, I just wanted to share with you, is a prediction model. So based on the previous historical data of 5 years, for example, you can easily predict, or it gives you a clear indication of what could be in future, whether inundation levels might change, or if it is agricultural field or different kind of fields, whether the area of region of interest will be affected. So that historical data will give you clear guidance. So in this model, you can see training and test data sets and windows and horizons are set, and then error matrices are generated through the 2 different DL models. These are the 2 models, but there are many more deep learning models that can also be implemented. And then what I suggest is we need to identify and represent this data outcomes in a different way to compare and contrast between the outcomes to have a clear picture. So if you look at the second image on the screen, this is a comparison of DL models between naive forecast and CNN models. So the data outcomes revealed that comparatively, for example, CNN model performs well and gives you more accuracy. Similarly, you can have your ensemble of models or hybrid models, and then you can try to get into the details and infer the outcomes. Another sample statistics here on the models, DL models, which was on the same city, the case study which I referred earlier, have says that region of interest, for example, 4 land covers with RMSE error rates and the predictions are listed. This is generated through deep learning models. So you can always generate the statistics, the predictions through these models. And then further, you can also have kind of analysis on the changes detected. There are various techniques. I will not go into too much detail. If you are interested, you can always contact me, but you will have a lot of options or different techniques that can also be performed simultaneously or on the process data itself. So there are 2 different ways and identify the outcomes. The forecasting normally is performed using DL models, and then analysis is to be conducted and validated by some other method. So first of all, you did the coherent change detection techniques on satellite images. You identified the change patterns, and the second process was to implement deep learning models, and you identified the changes and you have a prediction. And the third stage is to validate that method by using different techniques such as image classifications, flood maps, such as this one, as an example, you can see, or you can have different techniques like supervised image classification techniques or unsupervised classification techniques, identifying the design patterns using time series, for example. That is also another way. And then maybe you can have some IoT based monitoring system as an additional data to validate these outcomes. In the end, before I conclude, I would also recommend you to go through and understand the meta-analysis, because when you talk about statistics, you're not just reviewing the outcomes or comparing the data and coming to conclusion. You need to also understand whether your experiment has been successful or not. So the hypothesis, what you had, and you p-value, what you might have get out of the whole project, in the end, should also be supported by things such as meta-analysis. Now, if you have heard the word effect size, so the effect size can reveal you on whether these results have been positively supporting the concerned authorities or not. There are various different types of effect sizes. You can Google meta-analysis, and there are some sample algorithms that can be implemented, and then you can get an idea of how it works. And in the overall conclusion and future scope, I would say an additional warning system also is beneficial for the authorities from the gathered statistics and the results, that they can always alert the concerned people to take necessary action. And also, like I said, you can have a combination of CDTs, change detection techniques, deep learning methods, and time series, and so on. So you can have more robust, trusted outcomes to identify these changes and patterns. Thank you very much. So if you have any question, you can please feel free to ask.
Sir, I have a question.
Yes.
So you talk about Senetal A, 1A, and it used to work for day and night. I just want to ask you, while capturing the images from the space, what is the exact frequency range from transmitting into the receiving end?
What is the exact, sorry?
Frequency range.
Yeah, see, different satellites images are available from different satellite imageries like Sentinel 1A and Sentinel 2, and there is Sentinel 3, and different satellite images have different resolutions based on the spatial resolution that are defined. For example, if it is a 10 m range, and then it supports the imageries in a way that, for example, if you are working on flood maps, so Sentinel 1A gives you much more accurate information, because it gives you a clear indication of land covers, distinction of land covers. For example, I just was talking to one of my colleagues today morning, that he was working on Sentinel 2 images, and was trying to create flood maps. They were not much clear in that context, whereas it was much easier for him to work on crop analysis, on vegetation. So it depends on how this frequency can support identifying the water, for example, water surface, and things like that. So Sentinel-1, I would recommend, has a good frequency to understand the water surface areas and supports in identifying change patterns for floods.
So, is there any lock-in range between a transmitter and a satellite? How we capture images from the satellite?
Well, this satellite captures the images.
Yes.
It's revolving around the clock.
Yes.
So it has the imagery data sets with them, and those images are quite high resolution spatial resolution images. You need to download this data, but you need to create subsets of region of interest.
Right.
And that particular region of interest, that can be enlarged, and then you can implement some transformation to it. For example, you can after subsets, you can implement let's say the pre-processing of those images and clear distinction to understand the different land covers. There are some techniques available. You need to follow.
Okay, thank you so much. Thank you so much.
You're welcome.
Any questions?
Okay, thank you very much for this opportunity. And I also thank Professor Wasim Akhtar Saab, the Chancellor, Dr. Nadeem Akhtar Saab, Pro Vice Chancellor, and all other dignitaries and the staff of Computer Application Department. Thank you.
Thank you, sir, for sharing your valuable research and insights with us. Your extensive experience and expertise in IT and research have provided us with a lot of valuable information. Thank you once again. Now, finally, we have an invited talk on data lakehouse evolution by Mr. Vijay Mishra from the Data and AI Business Unit at IBM Silicon Valley Lab, California, USA. He'll be joining us today virtually. Sir has an extensive background in software development and AI initiatives. He began his career in Kanpur, India, and has since worked with esteemed companies such as Siemens, Pitney Bowes, NetApp, HP, and VMware. Currently, he contributes to IBM's Data and AI Business Group, focusing on AI initiatives with the Watson platform. In addition to his professional achievements, Sir enjoys reading technical books and roller skating with his family. Please join me in welcoming Mr. Vijay Mishra, sir.
All right, let's get started. Little introduction about me. I'm Vijay Mishra. I'm working for IBM as a senior manager in watsonx.data group. It's a product based for the enterprise data needs. And before I start, I just want to say thanks to Dr. Tasneem and Dr. Farooq for inviting me and making me part of this seminar. Yeah, so let me share my screen here. All right, so today's topic is exploring the data lakehouse evolution. So before I go into the data lakehouse and talk about here are my three objectives. So first one is, explain what a data lakehouse is and how it differs from the data warehouse. And the second one is discuss the benefits of a data lakehouse in terms of how we can scale the data and how can we be more resilient in terms of data needs. And third objective is the provide real world examples of enterprises or companies who are using data lakehouse. So the very first thing comes up what a data lakehouse is. So it's a data architecture. Before a data lakehouse, they used to have the data warehouse, data lake, those kind of things. But now with the advent of new technologies and the cloud and all, data lakehouse is the new architecture. So data lakehouse is a modern data architecture that combines the feature of a data lake and the data warehouse. So basically, both of these paradigms of data architecture, they have their own benefits. So, but each one of have their limitations as well. So if you can combine both of them, then it becomes the data lake house, data lake plus data warehouse. So we took one term from each. What is data lake? Data lake is actually you can dump all of the enterprise data into any storage. It could be raw data and unstructured data and the semi-structured data or completely unstructured like images and video files. There could be some XML and JSON files which is semi-structured, and then you report or create reports and the business intelligence on top of that kind of data. So here comes the data lake, and now the data warehouse is where you have the structured data in form of table like RDBMS. You do all the analytics on the relational table. So these were the two paradigm used before, and but the question comes, why do we need this data architecture? We'll talk about that. And before that, I need to tell what is the today's problem and how enterprises, every enterprise needs to have a solution for these kind of problems. First of all, there's more data. Data is increasing every day, like every organization. We have more images, more videos thanks to mobile phone. We all take photos, pictures, videos. So there would be 250% growth of data in the next 5 years. That's the kind of new study. And data actually is stored in the multiple locations. So there could be multiple copies of the data. It could be in the cloud, it could be in your on-premise data center, or it could be several locations basically. So 82% of companies have they are inhibited by data silos. So data silo is a completely different problem. Like you can have data only at one place, and there's no mechanism to to access that data. All of people have to connect to that data silo. So it's kind of very difficult problem, if you have data silo, because you need data availability all the time. And if that data silo is not available, then you are kind of business discontinuity happens, and then you have to cater to or resolve that business discontinuity. So another problem is like data is in the complex forms. It could be document, it could be images, videos, and more. So like 80% of time people spend or enterprises spend in data cleaning, integration, and preparation, because there are different kind of data. And the fourth one is the poor quality. If you have the data available in the different geographies, that there are chances that your data is not synced, or one site has a more relevant data, more recent data than as compared to other. So this is one of the problem, because if data is not synced, then one or other way you lose the value of the data. So poor quality of data is one of the problem. But I think the first point is why you need a data architecture, right? So I think the very first thing any businesses or any business face is that they have to answer some of the questions, right? But the biggest problem is how to ask the right kind of questions. So for that, you need a data platform. Data platform in the sense that where you can store all the data, and when you need, since it has all the data, you can ask, for example, like how much sales it would be for my company, for how much revenue I would be generating. So those kind of things. So I think for answering those questions, you need the data platform. But in any like in the business world, we do the commercial building. How do we make commercial building? You need a good architecture, good template, good kind of blueprint for that building. The similar thing is here in the data architecture. You need to have good design, and the very first two things which comes to kind of data platform comes to it's a data ingestion, and that you should ingest the data. And second thing is how do you store the data? So data storage is, and so data ingestion and data storage are two primary things. So to implement such data platform, one needs a robust data architecture, one that can help you define the core components of data platform and establish the design principles for putting it into the practice. So traditionally, organizations have used data lakes and data warehouse to implement their data platforms. But lakehouse is actually, it's the architecture is one such modern architecture pattern that has developed in last few years and has become a popular choice for the data architects who are designing such data platforms. Little bit of history about how it has evolved. So if we talk about late 1990s, it started with a data warehouse. Large organizations, they used to store data in their big costly data warehouses, and they used to run all sorts of dashboards and business reports on that data warehouse. So, but you have to spend money. You have to high upfront cost was there, but it was only available for the structured data. And before you put any data to data warehouse, and it is ready for your queries, you do need to do ETLs, that is extract, transform, and load process. So ETL was required, and there was one more problem. There's a vendor locking. Like you buy it from organization ABC, this data warehouse, and you are locked in kind of to that data warehouse because they have their own proprietary engine, they have their own data format. So there was a very less of a movement from one one enterprise server data warehouse to another data warehouse. So there was very less movement. So that was the problem with the data warehouse initially. Then early 2000, there came a concept of data lake. So data lake is nothing but it's a platform where you can dump all the data, whether structured, unstructured, or any form of data, and then you can run the dashboards and reports. With a data lake, actually, it was very cheap, but the data quality was poor because you are dumping all the data and you cannot segregate what data is what. So that was the problem with the data lake. And then I think when the cloud came, then it came as a cloud data warehouse, and cloud providers they started providing the data warehouse in the cloud. So it actually started, solve some of the problems of, you in the sense that you don't have to buy your own hardware, and you can offload that, capex expenses to the cloud provider. So cloud data warehouse came, but again the problem was it was a warehouse, so you have the very limited machine learning and AI use cases for this kind of warehouse. Then lastly, it came the data lake house, which is the today's topic. So actually it caters to the both BI and AI use cases, business intelligence and artificial intelligence. So BI, when we talk about BI, we talk about dashboards and reports, which runs on the relational data or some sort of structured data. AI could be run on any kind of data. So artificial data, for that you need cheaper storage, because with these days a lot of data is there, and if you cannot put all the data in the data warehouse because it's very costly, as well as you have proprietary engine, so you cannot have the data movability. So most enterprises today require two-tier architecture actually. So they have the data lake and data warehouse both, and they try to keep sync all the data, keep in sync all the data, but sometimes when one schema changes in the data lake, then you worry about changing it into your data warehouse. So that's one of the issue with the syncing the data lake with the data warehouse. And data warehouse, of course, it had the proprietary engine and the data lake storage. Moving on, so let's talk about what is data warehouse and how it works. So the diagram I'm displaying here, it's a typical example where you have multiple sources, source system 1, 2, 3. It could be your any kind of data, and this is structured, and then structured data has to go through the ETL process, extract, transform, and load. Because you could have it's a raw data. There might be some empty fields, there might be some null values, there might be some some mistake by the human user, and while filling the data, and the data is not proper. Instead of string, you have the int. So that kind of problems in the data should be eliminated through the ETL process, and then we put it into the data warehouse storage, and then you can do all the reports and dashboards on this structured data. So here is the process depicting the data warehouse, how the reports and dashboards are created. And the second thing is data lake, where you have structured, unstructured, and semi-structured data. And you put it, like kind of dump it into the data lake, and you can have reports and dashboards on those that kind of data, structured data. And if it is unstructured, then you can run the AI and ML workloads. So data lake, it does not have any ETL process in between, as we have seen in the data warehouse. So again, the cloud data lake games, cloud data lake, actually it has AI ML workload. You can run on the cloud data lake, and then you can do that ELT and ETL process and put that data into the cloud data warehouse. So ETL and ELT, I think when it started, everything was ETL, because you extract the data from the source system, transform it, and then load it into the warehouse. With the advent of compute and cheap storage, what happens, like you extract it from the source system, you load it immediately into your system, and then you transform it there, because now you have the compute available there itself. So that's the use case of cloud data lake and the cloud data warehouse. It could be within a same cloud service provider, and you can run the AI ML workloads on the cloud data lake, and reports and dashboard, you can get it from transforming it into or moving it into the cloud data warehouse. So that's the use case of cloud data warehouse and cloud data lake. There are certain features like data lake provides, and there are certain feature data warehouse provides. So first of all, data lake is highly available. Like it is, it's cheap. Like example would be Amazon S3, KDLS, Azure Data Lake Storage, or DCS, Google Cloud Storage. So in all these storage, you can have the object storage. You can put any kind of data XLS file, doc file, or maybe the images and video files, and it would be highly durable. There we are talking about 5 nines or 11 nines of durability. It can have all kind of data, structured, semi-structured, and unstructured, and it is a very good use case for the AI and ML workloads. On the other hand, data warehouse have this kind of features where first of all, it has the ACET support, atomicity, durability and atomicity, consistency, isolate, and durability. All ACET properties of a relational database, better performance, because of course you are storing it in form of structured tables, and there's support for updates and deletes. There's a fine grain access control and support for SQL and support for BI workloads. So all the dashboards and reports, they are pretty good example in the data warehouse use cases. You can generate through data warehouse. So BI use cases are very well catered through the data warehouse, and data lakehouse is very conducive for AI and ML. But the question comes, why we need this kind of data architecture. So as we talk about data architecture, we need a robust architecture for any building, right? If we are making any building, then we need innovative design, we need experienced architect, we need army of construction workers. So similar thing is applicable to the data platform, where you should have a good architecture for your data platform. The data architecture helps you define the foundational activities that you need to do to start building your platform. So any data platform has certain components. They are bound to have those components for a robust data platform. So the very first thing is data ingestion. Like you should be able to ingest the data into the data platform. Then you should have the data storage and data transformation, and then fourth thing is comes like how do you consume that data. So let me share this screen. So components of data platform, there are these components you're seeing on the screen. There could be source system, those are internal systems, and there could be structured, semi-structured, unstructured kind of data, like for example, your emails, your CRM system, your ERP system for any enterprise, and all images, videos. There's all three kinds of data in any organization, and there's another feature in terms of velocity, that it could be batch, it could be near real time, or it could be streaming. So batch data is something like, for example, you are generating the electrical utility bills for all the customers of your electricity company. So you'll give all the customers data, their usage data to Hadoop or any big data platform, and it would generate in the batches, because it has all the data, all months data, and it is generated in a batch. Near real-time system, they have kind of smaller data, or you can call it the micro batches. So it would not be that much duration, but data would be coming through the system in a, let's say, 1 hour time period, or maybe sometimes it is 1 minute as well. So depending on the system, but that is called the near real time system. Third one is the streaming data, where you cannot delay the data, and for example, the clickstream data, for example, customer or server logs, and the stock exchange data. So every second, every millisecond, it is changing, and if you miss that data, then you miss the value of that data. So I think that is very, very important in the streaming kind of data. So whether it's internal system or whether it's external system could be, for example, you need currency conversion rates. So you need to have the external data from outside from your organization. So that is one example of external system. All this data, whether it's a batch, near real time, or streaming, all you have to ingest in your data platform first. And then after ingesting, you have the data processing and the transformation. What data transformation is actually that you sometimes data is raw, sometimes fields are not correct, sometimes fields are null, and sometimes they're duplicated values. So you need to make it good data before saving it into the actual data storage. So data validation comes into the picture, and data validation and cleansing needs to be done on that data. Data transformation is like you have the same data, but you have the, for example, I'll give one example where you have the different part of the words have the different date formats, like DDMMY and MMDDY. So you want to save it in a correct format and in one format. Correct is not the correct term, but so you want to save it in the one format, which you can always say that okay, data is stored in this format, and use it everywhere in a uniform way. And sometimes data curation and serving is required. Curation in the sense that you want to divide the data in the product IDs, or you want to divide it for a certain months time period. So this activity also comes under the data processing and transformation. And then there comes the data storage part. Data storage is like when you ingest the data, how would you store the data? So it could be normal S3 storage, or it could be any purpose-built storage. So I took the example before, I give the example before that it could be S3 or it could be ADLS or any other Google Cloud storage. You save it in the object format, and any object could be stored, any data object could be stored in the general storage. Purpose-built storage are certain specific purpose. For example, if you have RDBMS, data RDBMS, relational database. So that is called the OLTP workload because you have online transaction processing, and you save the data in the table format. And but if you have to do any analytics on top of this kind of relational table, then you should have the data warehouse that is called the OLAP workloads, online analytical processing. And normally industry practice is that you don't want to do analytics on your production data or production RDBMS because the reason is it would give your customer serving queries or customer serving process. So normally people put data warehouse and RDBMS separately. And one other example of purpose-built storage, it could be in-memory database. In-memory database for the faster data retrieval. Sometimes you need data very fast, so you have the one kind of purpose-built in-memory database. And then there's another variety, graph database, where you have you have to store the connections and the relations. Like, for example, if you take the example of LinkedIn, who is connected to what, the people's are kind of nodes, and their connection, to whom they are connected, is actually kind of relation. And the same thing is with the social networking or also, the Facebook and other. So if for that kind of storage, you need purpose-built storage. Okay, all right. So, and apart from these, data processing and transformation component, there are some common services like metadata management. So what is metadata? Metadata is data about data. Like you store information about tables, what columns they have. And so this sort of, creates a faster query system, because when you do query, you have the data, you don't necessarily need to go to that table, and you query this metadata for the faster response. So metadata management is one of the, like people use Hive data management or HMS, Hive Metastore for this purpose. And the second component of the common services is data governance and security. So data governance is a kind of policy on rules or standards that ensures that all data processes follow the same formal guidelines. So these guidelines helps to ensure data is trustworthy, it's high quality data, and delivers some value to the enterprise and organization. And secure, of course, data security is a part of data platform, that your data is secure, and it cannot be easily accessible, and there are some permissions and rules around that data. So that should be inbuilt thing into any data platform. And data operations is, where you can move the data from your data platform to other databases or other kind of data systems. And a lot of operations could be performed. So that all comes into the data operations. So these are overall kind of components. I'm explaining that in any data platform, you should have, these components. The last part, which I have not covered, is the data consumption and delivery, which is very important part, because that's the very reason that we are creating this data platform. So there are 4 use cases: data consumption and delivery, like business intelligence, that you should be able to create the reports and dashboards and other things. Second thing is like there are certain meetings where people ask how much revenue would be in the next quarter, or how much we would be generating the revenue. So those kind of things can be answered by the ad hoc queries. So you should have the interactive query system also, the data platform. And other thing is downstream applications or the API, they call those application, those APIs, and you should be able to get your answer. So basically it's a REST kind of API where you just call this API, and this would complete your query and whatever operation you want to perform. And last is AI and ML use case, where you have your models and everything is running, and you just provide this data, and they predict, they do a lot of recommendation, and they provide those values, forecasting and recommendations through the models. So the question comes, why do we need a new data architecture like lake house? So data warehouses and data lakes have remained the most popular architecture for implementing data platform, but there's new approach. Why? Because it's a traditional architecture have several limitations. There have been multiple technological advancement also in last few years, or innovations within cloud space and the maturity of open source technologies. So some of these new architecture, or the new innovations, like people started using two-tier architecture, combining a data lake, and data warehouse to support BI analytics and AI, artificial intelligence, both on the same platform. And they leverage hybrid transactional kind of processing in one platform, that is called the HTAP technologies. And the third thing, people tried building modern cloud data warehouse that can process unstructured data along with the structured and semi-structured data. So these are the people have tried these kind of things to overcome the limitations of data warehouse and data lakes. So all of these efforts indicated a need for a new architectural patterns that can support the implementation of a new simple unified platform that can handle all data formats and a diverse set of use cases to help users easily consume data, right? Diverse case means like you should be catered to business intelligence use cases. You should be able to do the ad hoc query. You should be able to support all your applications. Now we are in the age of apps. So apps should be able to call your APIs pretty quickly. And there was a need for ACID support, again, like RDBMS ACID support for the excellent BI performance and access control mechanism of a data warehouse, which was not possible in the data lake, because you are dumping all the data, and you need some sort of structure in the data before you run a query on, right? So you needed one unified data platform where you can put all the data and you run all your queries. It's like data warehouse kind of capability on your data lakes, right? So, and the third thing is the provide the scalability and the cost efficiency and the flexibility of the data lake. So, so I think I should move forward and tell what actually is the architecture of a lakehouse. Sorry. So lakehouse is nothing but it's a combination of your storage layer and your compute layer. And storage layer has a cloud storage, as I was talking about. You dump all your data, and then but the normal question people ask, if you're dumping all the data, then how do you query the data? And it's a different kind of files, structured, unstructured. So somebody needs to create some kind of structure before you do query. So for that, we use the open file format. And open file format could be your any Parquet or ORC, or there are different kinds of open file. Open in the sense that is open source. Anybody can have those kind of file format, and they can use it in their enterprises. So that's the one big move from the proprietary software, because you don't have to buy their companies big storage and an engine and a proprietary engine that can only work with one type of format, not with others. So I think open file format came, and that's why the Lakehouse is an open data platform where you're not logged in with any specific vendor. You just have to have your own object storage and open file format, and then there's an additional transactional layer on top of that, that is open table format. So I think there are three main open table format. One is Apache Hudi, second is Apache Iceberg, and third one is by a company called Databricks, and they created their data lake, Delta Lake kind of proprietary platform. So to some part they have open source some of it, and they have some part is their commercial uses, but still there are three open table format, and they kind of provide additional transactional layer on your data storage. And Lakehouse compute layer is like number of you can have your processing engine. Example of processing engine could be Presto, or it could be Presto, Trino, or there are some others. I think Spark, Presto, Trino, Hive. These kind of they are the example of open source engine which enterprises are using in creating their data platform. And there's some commercial engines also, like companies like Dreamio, Starburst, Databricks, Snowflake. They have their own engines, but you're not bound to. If you want to create your own lakehouse, you can do it. You just need to have the object storage on any cloud provider, and you can use any of the open source Spark, Presto, or Trino engine. And so basically, these two things comprise the lakehouse storage and lakehouse compute layer. So if we go into the granular architecture of a data lakehouse, we see it's all supports all kind of workloads. And the first top is the business intelligence, and then ad hoc and interactive analysis, which is actually nothing but you should be able to run the query, and you should be able to downstream. You should be able to support the downstream applications and the API. And the fourth use case is AI and ML. And the below layer should have any open source processing engine or commercial processing engine. Open source, I think I give the example. It could be Presto. It's a lot of companies are using, like Uber, Facebook, for their data queries and other things. So they are using this Presto and Trino for querying their systems, and they are running millions of queries in a day using these technologies. All right, so open table format, I gave the example. Delta Lake is by Databricks, Apache Hudi, and all these are all open source. Apache Iceberg, it started from Netflix and provides ACID properties on your unstructured data, and it's pretty good in the sense that it's running on your data, unstructured data, and it provides certain sort of structure so that you can run your query on. And open file format, Parquet, Avro, ORC, pretty popular format. So you just have, you need to have these on top of your storage or your object storage, and then you can access a transactional layer. You put the table format, and then you should be able to run the query. So basically, this is the example of lakehouse in the more granular form. That below layer is the storage layer, and then you can run the queries through the compute layer using this open table format. So this Iceberg and Hoodie and Delta Lake, they change the whole thing in the data query and the data processing framework by introducing this feature on top of unstructured data. Yeah, so actually, this is the same figure. Simple, just to emphasize that you could have open source processing engine, and you could have commercial also. It could be from Dremio, Starburst, Databricks, or Snowflake, or it could be Spark, Presto, Trino, or Hive. Moving on, so if you see the data lakehouse, there are only two components. You separate storage and the separate compute. So and one of the big selling point, or what you call the big feature of the lakehouse, is that it has the single storage tier with dedicated warehouse kind of thing. The warehouse like performance on the data lake. How do you provide this performance? By using optimization lever and the storage and the compute layer. So there are certain settings you can do with with this table format and the file format, and they would give you warehouse like performance on top of data lake. And other thing is you have the decoupled architecture with a separate storage and the compute. So if you see the biggest, the advantage of this figure is that, or always the architecture is that you can scale your storage independently of your, right side, your compute, right? So you can put more storage, you can put object storage, and on the other hand, you can have the different variants of Spark or Presto or Trino. So scaling, there's no limit, and both of these components can be scaled altogether in separately in a different way. Okay, moving on. Yeah, so cloud storage, it could be, so there's a similar thing. Actually, I was telling just a layer by layer approach. So cloud storage, it could be S3, AWS or GCS. Amazon and Azure Data Lake Storage and Google Cloud Storage, and then coupled with the open file format, open table format, and then this is your storage part. Second layer, you could have a file format. You could have Parquet, Avro, or ORC, and these are all open table for open file format, and then open table format, right? So basically, these three things, these three are the popular variant of any table format, and they gives ACID properties, a lot of other properties, schema evaluation, and schema restriction. Those all kind of things are pretty cool features in the open table format, where you can give structure to your raw data and do the query on top of that. So I think we are near the end of this talk. So I just want to give you the benefits of Lakehouse. So the very first thing is that no additional efforts are required to sync data between data lake and data warehouse. Because if you traditionally people used to both the kind of architectures, and they are always bothered about whether their data is in sync or not. So since Lakehouse is a unified data architecture, because you are storing data only in one object storage. There's only single one object storage, right? There's no data lake, there's no data warehouse, but you provide data warehouse kind of a thing on top of data lake. So you don't need to worry about changing the data formats. The second advantage is the data governance. Data governance, like compliance. There are certain compliance rules you have to follow, and data governance, it becomes much easier in Lakehouse
as you have to apply access controls at only one place, not at the data lake and the data warehouse, because you have the storage at one place, so you have the data governance at only one place. And ML workloads also can read data from the lakehouse directly, accessing underlying, Parquet, Evro, or ORC storage files. So this actually removes the need to copy any aggregated data from the warehouse to the lake if required by the ML workloads. So you can do the ML workloads, AI and BI, as I always say, that it supports both. So Lakehouse is the upcoming architecture, and people are using it. It's an open format, and you are not, you don't feel that you are locked into any one vendor, and you have to buy, from them only. So you can, it's like a Lego block. You can change it at any time based upon your need. Okay, moving on. So 73% data teams using data lakehouse now, as per the latest survey. And IBM is one of the leading organization. We provide Watson-X.data to save all your data. It's a hybrid platform. It's an open data lakehouse, so you can run your all your queries. You can have your dashboard ready. You can have your reports ready. You can query the data, and you can directly call your APIs. And the most important thing is this can pave the way for your all the AI needs or ML needs. So Watson-X.data is a data platform, and then you can feed this data into all your AI systems. So Watson-X.data, it's a leading platform, a data lake house. There are some others too. Databricks also has some lakehouse solution, and so some of the other companies. Oracle is also into this, but Watson-X.data is the leading data provider for the lakehouse needs and your unified storage architecture and query needs. I think we are top of the hour. Thank you, everyone, and for listening to me. And if you have any query, I would be available at this email ID, vmishra@ibm.com. So yeah, thank you, everyone, and that ends my talk. Thank you.
Thank you, sir, for your engaging presentation and for sharing your experiences and insights with us. We are grateful to all our speakers for their valuable contributions. The knowledge and expertise they have shared today will undoubtedly inspire further discussions and research. Thank you, everyone, for your attention and participation. Now, I would request Dr. Tasneem Ahmed, sir, to present memento to our keynote speaker, Dr. Mohammad Siddiq, sir. Let's give another round of applause, please. Thank you, sir. Now we are adjourned for a lunch break, and this marks the end of day one. We'll reconvene at 2 p.m., where technical presentations will run in parallel in all the four halls, hall 1, 2, 3, and 4. Thank you, everyone, for your gracious presence. Thank you.
Okay, thank you. Should we start? Okay, thank you for the introduction and for the invitation. to give a talk in this wonderful event. The purpose of this talk is to have an interactive session with the researchers who have the research interest related to intelligent fault diagnosis systems and intelligent fault tolerant control, especially for the wind turbines. So over the years, we are working with the topic related to intelligent fault diagnosis systems. In the past, we have done some papers related to fault diagnosis systems for the induction motors, generators, and centrifugal pumps. And currently, our focus of our research group is related to fault diagnosis system and fault tolerant control system, especially for the wind turbines. There are some research collaboration opportunities for international researchers under these projects. If anyone interested, then he can contact me on the given contact number and the email ID. So if we introduce the wind turbines, they are basically increasingly important for the renewable energy and renewable power generation. The world is focusing to achieve the targets for 2030 and 2040 to convert the conventional power system to the renewable energy system. And wind turbines are one of the major components along with the solar power generation system. The wind turbines have the complex and large scale structure, and usually they operate in the remote locations like the offshore locations where there is a harsh environment and highly variable wind speeds, which create problems and create various type of faults for the wind turbines. Early detection and location of these faults is very important to plan the maintenance before the serious breakdown. So to detect the faults at the earliest stages, various type of techniques and various type of algorithms have been reported in the literature, and the new techniques are continuously being investigated by various research groups. So the fault diagnosis and fault tolerant control designs have been the subject of intensive research in the past decade and in the recently published papers. Significant progress has been made in several methods and control algorithms in the recent published literature. So this session will provide an overview of the most recent fault diagnosis techniques and fault tolerant control methods for the wind turbines. The wind energy is among the most promising and fastest growing sustainable energy sources in the world. This chart shows that the contribution of the wind energy is increasing exponentially year by year. Currently, they are getting around 10 gigawatt, and by 2030, they aim to double it. So this shows that there is a huge potential and huge market for the wind power generation systems in the future. For the wind turbines, by design, they have mostly the two types. One is the horizontal axis wind turbine called hot, and the other is a vertical axis wind turbine called watt. In the hot, the main rotor shaft and electrical generator are the top of the connected at the top of the tower, and the wind must be pointed into the wind, the direction of the turbine. In the watt, in the vertical construction, the main rotor shaft arranged vertically, and the generator and the gearbox can be placed near the ground. So that is the main difference. In the hot, the generator and gearbox are connected within the blade, and for the watt, the gearbox and generator can be placed near to the ground. And for watt does not need pointed into the wind direction, and it has relatively low rotational speed. These are the basic components of the wind turbines. It has the blade, it has the rotor, and the neckly, and the tower shaft. The small scale turbine components usually made of the aluminium, steel, and the copper structure, and the distribution of the material is given in this chart. So the maintenance issues of the wind turbines, whenever there is operation and maintenance, so we have to consider the maintenance cost. So the operation and maintenance cost of wind turbines are significant, especially for the large scale offshore wind turbines. The unscheduled maintenance resulting from the malfunctions in the system components, such as the yaw system, the rotor blades, the gearbox, the hydraulic system, the gearbox system, the control and power electronic system. The maintenance cost associated for this system is 30 to 60% of the total operational and maintenance cost. So which is the huge portion which is allocated for the operation and maintenance. And thus it's very important for the researchers to investigate how to lower the maintenance cost associated with the wind turbines. So the potential faults and the failure rates for the wind turbines are summarized in this table, which shows that the electrical components and the control systems, they are contributing around 41% of the total failure rates. Electrical components are around 23% and control systems are around 18% of the total failure rates. In the mechanical, the gearbox and mechanical brake system, they overall count to the 10%. And the rotor system, rotor blade and rotor hub system contribute around 12% of overall failure rates. So the fault detection and diagnosis system consists of the actuators and mainly the actuators and the sensors, as depicted in this block diagram. So the purpose of the fault detection and fault diagnosis system is to detect any fault which appear in any component of the wind turbine. It could be in any sensor failure, or it could be the actuator failure, gearbox failure, or any failure. So the purpose of FDD block is to detect the fault and diagnose the fault. So diagnose mean to detect the location of fault. If it's whether it's a gearbox, if any sensor, vibration sensor, temperature sensor, speed sensor, or whatever. So the system must know that whether the fault has occurred, and if fault has occurred, which type of fault, and what is the location of fault. So based on this FDD block, then the fault tolerant control strategy will be developed. So FDD methods basically are classified into three categories. It's a model-based technique, signal processing-based technique, and data-driven technique. So we will discuss these three techniques individually. The first one is the model-based technique. In model-based technique, we rely on the model of the wind turbine. This model can be either the physics-based model using the equations, or the estimated using an observer or another identification method. Faults are detected based on the residuals generated by the state variables or the model parameters estimations. And the most common model-based techniques are summarized in this table. Kalman filters are the famous in the model-based techniques, so they are utilized in the various research papers to detect and diagnose the fault. Also, some researchers have investigated LP observers, internal observers, unknown input observers, and also some of them have investigated fuzzy Shigino observers. Data-driven techniques rely on the data availability from the SCADA system. So usually the wind turbines have the SCADA system for the data collection and analysis. So data collected through the SCADA system is utilized in the data-driven techniques. It's an affordable solution basically because the SCADA is already the package which is installed during the installation of the wind turbine. So the just data from the SCADA can be utilized for the condition metering and fault diagnosis purpose. So some of the recent work on the data-driven techniques, it's through artificial neural networks, and it's further types, convolution neural networks and recurrent neural networks, fuzzy logic and neural networks, deep neural networks, adaptive neurofuzzy inference system. Some of the researchers have also investigated machine learning techniques. So these are all basically based on the artificial intelligence. Data-driven techniques, majority of the research is based on the artificial intelligence. And they are achieving very good performance metrics, especially accuracy is around 99%. Then next is the signal-based techniques. In the signal-based techniques, the data should be collected using the various strategies like the electrical measurements or the vibration signals using vibration sensors. Also, some researchers are utilizing the sound of the system to diagnose the faults, and also the thermal system to detect the temperature of the generator or various components like the gearbox, and then make decisions based on that signals. So signal processing usually is in the frequency analysis techniques. Statistical methods are used to extract the fault signatures. Usually they have the healthy signals already in the database, then they compare the ongoing real-time signal with the database and compare whether there is any fluctuation on specific fault frequencies or the statistical measurements. Based on those comparison, they give the decisions whether there is a fault or no fault. So the analysis could be in the frequency domain or in the time domain or in the time frequency domain. So in the fault detection and diagnosis, based on our literature study and based on our ongoing research and our project, we identified that there are still a lot of potential and future directions which should be addressed by the people who are working on the wind turbines fault diagnosis. The most of the existing fault detection and diagnosis techniques are often restricted to detect faults for specific components. For example, majority of the research is focusing on the gearbox faults within the wind turbines. For the future work, all type of faults must be considered. And if faults are appearing in simultaneous, for example, there is a gearbox faults, there is a bearing fault, there is the electrical fault, the control system, any sensor fault. So if the faults appear simultaneously, current research is not focusing on simultaneous faults. So there is a potential for the future researchers or the ongoing researchers to take this factor into consideration. Similarly, because the wind turbines are installed in the offshore locations and majority are in the remote locations, and if there is a environmental changes, for example, the wind speed go very high, sandstorms, or the weather changes, weather fluctuations. So this sudden changes are not addressed by the SCADA collection system due to the low sampling times. So the researcher can focus on this knowledge gap or this research gap, how they can address these sudden variations in the environment, so that there could be continuous fault detection and diagnosis systems, especially for the offshore wind turbines. Then another issue is the good data quality in data-driven techniques. So the data available from the wind farms, sometimes its quality is not good. The data loggers, sometimes they miss the data, or there are some outliers, or the sequence is not correct. So these type of issues with the data collection systems, they can also be addressed and can be taken as a future direction, especially for data-driven techniques. The data-driven approaches provide higher diagnostic accuracy. As I told, they are close to 100%, almost 99.5%. However, their accuracy is highly dependent on the data availability, because it's a data-driven technique. So if good data is available, then the results will be promising. But if the problem in the data collection, then the results will also be, not promising. Then the performance and accuracy of the model-based techniques rely on explicit physical or mathematical expressions. These mathematical expressions usually in the model-based techniques, because they involve the model of the wind turbines. So the exact information about the various components of the wind turbine is must to develop the model-based technique. So sometimes the supplier does not give the accurate information or the full information of the all components of the system. So that's the one limitation in the model-based techniques. Another challenge and future direction is the optimal selection and placement of the sensors and data acquisition devices for the fault detection and diagnosis system. So researchers have to decide how many sensors must be used, how many vibration sensors, how many acoustic sensors, acoustic emission sensors, temperature sensors, speed sensors. So the optimal selection to get the optimal performance, this is also one of the knowledge gap in the existing literature. So after you have diagnosed the fault, next is to develop the fault detection system, fault tolerant control system. So FTC design is to maintain the desirable performance and stability properties in the event of the fault, and to prevent the local fault from developing into system failures that can end the mission of the system and cause safety hazards for the people and for the environment. So the purpose of the fault tolerant control is to keep your system running when the fault has appeared. So the system must not immediately shut down, because it's a power system. So immediate shutdown of the wind turbine mean the immediate shutdown of the electricity. So this will affect overall performance of the grid station and the power distribution system. So that's why the fault tolerant control systems are important, and their purpose is to keep system working, to keep system running. And meanwhile, the maintenance engineers, they can start working on the the maintenance and they can plan the maintenance. They know the fault is coming. They know the gear is going to break. So they can plan their maintenance, they can schedule it, and the fault tolerant control system in this time, it will allow or it will keep the possible that the system keep working. In fault tolerant control, there are two main types. The passive fault tolerant control techniques and the active fault tolerant control techniques. In passive techniques, the robustness range of the baseline controller is specified to be wide enough to accommodate specified faults within the accepted performance specification. So here basically in the passive type, they already designed the fault tolerant control system with the all possible type of faults which can occur in the system, so that if let's say the vibration sensor is not working, if speed sensor has stopped to give the signal, if any other sensor has stopped to give the signal. So the system has already the knowledge about this one. So if any sensor will stop working, the fault tolerant control system will take the data or will assume the data for that sensor and will keep the system working in that scenario. And at the same time, it will give the signal to the maintenance engineers that some of the sensors or one of the sensor is out of working, so that they can plan their maintenance activity. So as this passive type of controllers, they are pre-planned controllers, and so there is a limitation in the fault scenarios. Maybe in the design, they have not counted all type of faults. Or let's say if they have counted 10 type of faults, but maybe there are some issues of misalignment which was not considered during the design of system. So the main disadvantage that the passive type of strategies, they cannot cover all type of faults. The second type of control strategy is the active fault tolerant control strategy. In this strategy, the fault detection unit, it will detect the fault, isolate the fault, and then initiate the reconfiguration mechanism. So this reconfiguration mechanism know that your temperature sensor is out of working. So it will give the signal to the controller, and the controller then will take the corrective action for that temperature sensor so that the system keep working. And meanwhile, the maintenance engineers, they can plan their, they can schedule their maintenance. So the problem with this type of control strategy is if there are the possibility of false alarms from the fault detection unit or the false isolation of the faults. For example, the problem was in the temperature sensor number 1, but the system has isolated the temperature sensor number 2. So this will be the issue. And also the false reconfiguration has been reported in most of the active fault tolerant control strategies. This table gives you the summary for various research papers which have been published for active and the passive fault tolerant control strategies. They are using Takagi Spino fuzzy system. They are using adaptive sliding mode control system, fuzzy simulated system, fuzzy Shigino system, along with the sliding mode control observer, time relay control strategy, fuzzy if-then rules, fractional order sliding mode control, and various other type of controls are being used under the fault tolerant control applications. So the main challenges and future work which we have summarized from the literature review, and some of these challenges we are addressing in our ongoing work. Most of existing fault-tolerant control techniques have been developed to mitigate faults in specific component. Control design capable of mitigating wide range of faults among various components are still rare. So fault-tolerant control strategy must be developed which incorporate all possible type of faults within the wind turbine system. Most of the fault-tolerant control approaches were designed with the assumption of availability of accurate information from FDD unit. But if your FDD unit is giving the false alarm, then your FTC is based on the FDI unit or FDD unit. So it means there is a possibility that there is a wrong initiation for the fault-tolerant control system. So this is the area where the researchers are focusing how to tackle the false alarm rates in the FDI system. Then most of the proposed approaches which are reported in the literature were validated using either a simulation study or the wind turbine benchmark model, and only consider limited fault scenarios. For example, majority of them is working on the bearing and the gear defects. So the more research efforts should be done towards validation using hardware in loop, high fidelity simulators considering the realistic fault scenarios. None of the existing literature has considered performance assessment of FTC in the experimental scale. So majority of the FTC systems, they are simulation based. There is a potential in the market to investigate the fault-tolerant control system in the experimental scale. And also compared to FDD techniques, existing literature for the wind turbines, there is a very less literature on the fault-tolerant control. So there is a huge potential for the researchers on the wind turbines to work on the to develop the new strategies and to improve the existing strategies for the fault-tolerant control for the wind turbines. So these are the references that we have consulted so far to develop our research strategy and to establish our research directions for our research group. And and we are actually looking for research collaboration as well worldwide. So if any of the attendees, if they are interested, they can contact our group to collaborate in the fault tolerant control or fault diagnosis. And also we have projects related to plant process control. So overall in the fault diagnosis and fault tolerant control and overall control system applications, we are open to develop research collaborations. Thank you for this conference organizers. Thank you for the Integral University team. Thank you to Dr. Saifur Rahman and all other friends for this invitation and for arrangements. So if you have any question, you are welcome.
Thank you, sir. Any questions? So since we are having no questions, thank you for your engaging presentation and for sharing your experiences and insights with us.
Okay, thank you, ma'am. Thank you.
Next, we are having an invited talk on inventory control and models of inventory management by Dr. Anu Sayal. Dr. Anu Sayal is currently a senior lecturer in mathematics and statistics at Taylor's Business School, Malaysia, which is ranked among the top 50 in Asia, and the business school ranks 91 globally. Dr. Sayal is a certified trainer of HRD Corp Malaysia and has over 16 years of teaching and research experience. She earned her bachelor's degree from Guru Nanak Dev University, Amritsar, and completed her post-graduation in mathematics from the same university. Dr. Sayal holds a PhD in mathematics from Uttarakhand Technical University, Dehradun. She has received numerous awards and accolades and authored numerous research papers in prestigious journals and conferences. Please join me in welcoming Dr. Anu Sayal, ma'am.
A very good afternoon to everyone. First of all, I would like to thank Integral University and the organizing committee for giving me this wonderful opportunity. Thank you so much. Can you please make me the host so that I can share my screen? I am unable to share my screen.
Just few minutes.
All right.
Yeah, it's done. You can share your screen.
All right. Let me check. Yes. Is it visible?
Yes, ma'am. It is visible.
All right. So my topic is inventory control and models of inventory management. Now, coming to the introduction part, basically what an inventory means. Inventory is basically a stock of goods, commodities, or other economic resources which we have stored so that the business runs in an efficient manner. And inventory, basically, it is the most important asset that a business possesses. It forms the backbone of a business. Mainly, it is sort of a revenue generation and subsequent earnings for the company's shareholders or the owners. So, efficient running of the inventory system is very, very important so that the business doesn't go into a phase of loss. Now, inventory management, this plays a very important role in setting up the efficient closed loop supply chains. That is the process of efficiently overseeing the constant flow of the units in and out of the existing inventory. In the inventory means the inflow of the raw materials, other resources, so that the products can be prepared and after that the finished products are being supplied. Now, the most important task here is inventory management because it is basically making a trade-off between the minimization of the total cost and maximization of the customer satisfaction or the profit as well. Now, in the real cases, what happens? These objectives, it is very difficult to satisfy because of great number of the factors which are involved here, and there are a lot many uncertainties in the market. Unpredictable events are there, like related to demand and supply of the commodities. So it is a bit difficult to achieve proper inventory management. Now, it is actually very important to apply a suitable control system and policy for each type of product. And inventory control, basically, it defines how often the stock level is reviewed to determine when and how much to order. Because if the stock level is not reviewed at regular intervals, what will happen is the inventory might run out of stock. And when there is a demand of the commodity in the market, it becomes very tough to fulfill that demand. So in that case, maybe the client or the customer is ready to wait for the next replenishment to arrive, or maybe they may even approach any other seller so that there will be a loss of sale in that case. So the business will definitely go into a phase of loss. The initial inventory models, they were primarily used for a single company and were optimized on total inventory cost in order to find out the appropriate time and the quantity that has to be ordered. Now, which were hence considered the main questions behind every inventory control model, and these will be the most important questions while managing the system of the inventory. Now, if we talk about supply chain, basically it is a network of facilities as well as the distribution options which perform the functions of procurement of materials, transformation of these materials to finished goods, and then supplying these finished goods to the customers. So it is a sort of a chain which starts from the manufacturing of goods and then supplying the finished products to the customers. Now, supply chain not only includes manufacturer and supplier. There are a lot many other things included in between. They are like the transporters, warehouse, retailers, customers as well. So supply chain speed as well as flexibility, this forms the key levers for competitive differentiation and increased profitability. Now, a company which provides the commodity to the customer in a short span of time definitely will gain more popularity and will be able to make more profit as compared to the others. So faster the supply chain, the better company can respond to changing market situation, and thus it needs less inventory, which results in higher return on the capital which has been invested in the business. So we have different types of the inventory system. The first one is the raw material inventory. Now, raw material inventory is the one in which there are raw materials and other supplies like parts, components. These are actually used for preparing the finished products. Then work in process inventory, again, it refers to the kind of raw material supply or other components, spare parts, which can be actually used in the manufacturing process in order to form the finished goods. And these finished goods are being supplied to the customers. Next, we have MRO inventories or the spare part inventories. Now, MRO here refers to maintenance, repairs, and operating supplies, which are consumed during the production process. And generally, they do not form part of the product, but they are used in forming the finished product. So they are referred to as spare part inventories. The next one is finished inventory. Finished inventory here refers to the finished product, that is the completed product which is ready for sale in the market. So in a manufacturing unit, they are the final output of the entire production process. So whatever production process is being carried out, whatever output we get from there, they are the finished inventories. Now coming to the next topic, that is the inventory cost. There are different types of costs involved in the inventory process. So mainly we have the 5 types of costs which are associated with the inventory system. The first one is the holding or the carrying cost. Now it is associated with holding or carrying the system of inventory. Basically, this includes the cost which is associated with storage facilities. We are trying to store the raw materials, the other goods, maybe the machinery. And also it includes handling cost, handling the various, let's say, raw materials, machinery. Then insurance is also there, breakage, some sort of breakage of the goods is there. So that cost is also involved here. Obsolescence, sometimes the product becomes outdated, so it has to be disposed of. So that cost is also included. Then depreciation is there. Taxes are also imposed. Then the opportunity cost of the capital, that is also included here in the holding or the carrying cost. Next, we have the ordering cost, the total cost that deals with the creation as well as release of the purchase order. Now, if any kind of purchase order is received by the company, what will happen? A cost is involved, which actually deals with creation of that product and release of that purchase order. So along with its receipt and inspection of the product. Now, this deals with typing, calling, transportation, receiving, etc. Now, this cost does not depend on the quantity order. This cost, basically, it is free of the quantity that has been ordered. Maybe, let's say, 1 unit of the commodity is ordered, or maybe 100 units of the commodity are ordered. So it does not depend on the quantity that has been ordered. Next, we have the shortage cost or the stock out cost. Now, this cost arises whenever there is a shortage of the goods or commodities in the inventory. Now, suppose a customer places an order. What happens? That good is not readily available in the inventory. So maybe the customer will wait for the product to arrive in the inventory, or maybe the customer will approach the other seller in order to get the product. So if the customer approaches the other seller to get the product, what will happen is there will be a shortage cost. the company will lose the business, due to which a cost will be incurred. So that is the shortage cost due to the unavailability of the goods in the inventory stock. Now, this is basically a result of the unfulfilled demand, since we are not able to fulfill the demand of the customer at that particular instant of time. So this loss due to losing a specific sale, the customer's goodwill or future may also be lost. Next, we have the setup cost. Setup cost, basically, it is a fixed cost. It is associated with purchasing the raw materials, manufacturing cost dealing with setting up of machinery, which is used in the production process. Then it may be line conversion, equipment changeover, then report preparation, maybe the wages which are being paid to the workers. So all the costs altogether, they form up the setup cost, that is setting up the complete system of the inventory. Then the cost of the item, basically it is associated with the product, the cost of the product. Now, inventory control, as already I told you, inventory control, basically it is a technique of maintaining the size of the inventory at some desired level in the view that best economic interest of the organization can be reached. That means the organization can make the maximum profit out of it. Now, for this, a proper and optimal strategy for inventory control is very, very important, and this strategy has to be followed for increasing the efficiency of the use of resources, making assets available which have been stored in the form of stock of goods, etc. Then the most important parameters are there which have to be considered so that the inventory control can be achieved, and these parameters are: what should be the size of the order of the inventory replenishment? If inventory replenishment is there, then size of order has to be determined. Then what should be the replenishment order of the inventory system be placed? When do we need to place that order? That is the replenishment order, so that the inventory level is maintained and inventory control can be followed in the accurate manner. Now, inventory management reduces the above listed problems and it makes the system more profitable. So if we follow the sequence and we keep a check on these parameters or factors, then obviously inventory control will be maintained and inventory will never run out of stock. Now, there are numerous models of inventory management depending on information as well as properties which are associated with the systems that we are actually considering. So the model of inventory system in which values of the model parameters are well defined, those models are known as deterministic models. So if we know the values of all the parameters associated with the model, then it is a deterministic model. Now, if the values of the parameters are a sort of random variables, that means they can take up different values. In that case, the model is a stochastic or probabilistic model. Now, if there is no change in the parameters of the model, then such model would be a static model. It remains the same all throughout. Now, if there is a change in the parameters of the model, in that case, the model would be a dynamic model. Now, the models of the inventory are classified in the following sequence. Now, considering the different type of uncertainties which are present, we have different types of models of the inventory management. Now, here, the fuzzy models of the inventory management control, they are the economic order quantity models, economic production quantity models, joint economic lot sizing models, continuous review system models, periodic review system models. So these are the different types of fuzzy models of the inventory control. Now, coming to the first model, that is economic order quantity model. This is popularly known as EOQ model. Now, this model basically it involves the fixed order size. A fixed order size is there in this model and it is known as EOQ model. Now, this model is a sort of a formula for obtaining the least carrying cost and ordering cost by finding the optimal order size. So basically in this model, we obtain a formula for finding the least carrying cost and ordering cost by finding the optimal order size. What is the optimal order size that should be placed? Now, there are certain assumptions in this model. The basic assumptions are the demand here is constant with respect to time and it is known. Then the shortages are not at all allowed in this model. Then there is a constant lead time for the order, for the replenishment to be there. Then all the order quantity received at once. Then this model was developed by Ford W. Harris in the year 1913 and was published in factory in 1913 in the Magazine of Management. Now, a lot of researches were carried out using this model. K.S. Park was the first researcher who applied this fuzzy set theory, and he developed a single commodity model of the inventory system having the fuzzy parameters, that is involving uncertainty, whenever uncertainty is there in the market. Now, in this case, we have the EOQ variables. Now, the following variables are used to denote. Here we have D, that is the orders per year. In a year, how many orders are received? Then C naught is the cost per order. Q is the order size. CC is the carrying cost. TC is the total annual inventory cost. Now, if we want to calculate the annual ordering cost, we use this formula, that is C naught D divided by Q, where D is the orders per year, C naught is the cost per order, Q is the order size. Now, if we want to calculate the annual carrying cost, then we have the formula, that is CCQ divided by 2, again, where Q refers to the order size and CC refers to the carrying cost. Now, the total annual cost is the sum total of these two costs. That is, we added the two costs, that is C naught D divided by Q plus CCQ divided by 2, where D refers to the orders per year, C naught is the cost per order, Q is the order size, CC is the carrying cost, T is the total annual inventory cost. So this is how we calculate the total annual cost in case of the EOQ model. Now, the optimal order quantity that needs to be ordered so that inventory control is maintained, as well as we can maximize the profit and minimize the cost of production. We have the optimal order quantity, which is given by this formula, that is square root of C naught D divided by CC. Again, here the variables are D, that is the orders per year, C naught is the cost per order, Q is the order size, CC is the carrying cost, TC is the total annual inventory cost. Now, coming to the next model, that is economic production quantity model, which is popularly known as EPQ model. Now, this EPQ model, basically, it is used to obtain the quantity of the commodity which has to be ordered by the company or the retailer, focusing on minimizing the total cost of the inventory system. So basically, the main purpose of these models is we have to minimize the cost of production and maximize the profit. Now, the cost is minimized by maintaining a balance between holding cost and the average ordering cost, which is taken as fixed. So in this case, the holding cost and the average ordering cost of the system is taken as a fixed number. Now, EPQ model was proposed by E.W. Taft in the year 1918, and it is an extension of the basic EOQ model. So it is a kind of extension of EOQ model, which was developed in the year 1930. So there is a wide application of EPQ model. Now, in order to add realistic values to the EPQ model, various assumptions have been taken into consideration. Now, the basic assumptions of the EPQ model are only one product is involved here. We are just considering one product, and the annual demand requirements are known to us. That is what all would be the annual requirement for that product. That is also known to us. The usage rate here is constant. It doesn't change at all. It is a fixed variable. Then the usage occurs continually, but production occurs periodically. So usage of that commodity is in a continuous manner, but the production cycle repeats itself again and again at certain intervals. Then production rate here is constant. The lead time does not vary. There are no quantity discounts. Then, due to the decrease in the number of natural resources and increase in cost of raw materials, the research activities have become very popular in this domain. Now, in the year 1998, Lee and Yao, they proposed the EPQ model in modified manner, and that was having different forms of input parameters in the form of fuzzy variables. So in this model, fuzzy variables were included as there are a lot of uncertainties in the market. As we look back to the COVID situation, which there was widespread uncertainty. We did not even know what is going to happen tomorrow. So that is why uncertain variables, that is the fuzzy variables, were introduced in this model so that we can get better output, better results. Now here the per day demand, and production quantity is taken into consideration. So basically, we are considering the per day demand and production quantity, because we are not sure like what would be the demand of the commodity in the future. Maybe on the next day also, we are not sure about it. So we are considering every day's demand and production. Next, we have the joint economic lot sizing models. Now, the joint economic lot sizing models of the inventory system, they deal with the issue relating to the coordination between the buyer and the seller. Whenever we want to obtain or whenever we want to study the coordination between the buyer as well as seller, in that case, we study the joint economic lot sizing models. Now, the main motive of these models is the development of joint and coordinated strategy of the inventory system, which deals with buyer-seller and has higher benefits in comparison with inventory strategy of each member, which is non-coordinated. So a coordination is required in this model because we are basically studying the relationship between the buyer and the seller and the strategies which have to be adopted. Next, we have the single period model. Now, single period model, the most important example of this model is the news vendor model. This is an appropriate example of a single period model of the inventory system. Now, basically, this is a probabilistic model which aims to obtain the order quantity that minimizes the shortage cost and also the inventory holding cost. So it is a probabilistic model, means the variables here will be variable. Okay, the values of the variables are not fixed. They will vary with time, with other conditions, maybe with climatic conditions, with other conditions, there will be a variation in the parameters. Now, D. Petrovic in the year 1996 designed the first single period model of the inventory system. He also proposed the concept of fuzzy set of second level. Now, the methods involving S fuzzification and arithmetic defuzzification. Now, whenever we want to study the fuzzy variables, first of all, we need to convert the crisp variables into fuzzy variables by using fuzzification techniques. Once we have obtained our solution, again, we have to convert that solution by using defuzzification techniques into crisp variables so that we can get the overall solution. Next, we have the multi-period models. The basic difference that exists between single period and multi-period model of inventory system is that in case of multi-period model, we have a leftover stock from previous period, due to which an optimal choice of order quantity becomes very complicated. So the basic difference is we have some sort of leftover stock from the period from the previous period, and that becomes very complicated because now we are considering the multi-period models. Now, in case of applications related to real world, the decisions related to production and inventory are dependent on each other and also on temporal nature. Now, in a multi-period model, all the items unsold at the end of one period are available in the next period. Now, suppose we have a stock of goods which are left over in the inventory. This stock of goods was prepared in the, let's say, in the first period. Now, in the second period of production, again, the goods are manufactured and brought to the inventory, and they are stored in the inventory. So, in the second period, when the goods are being supplied in the market, we will be considering those goods which are left over from the first period. So, the process becomes a little troublesome, a little complicated because we cannot generalize the things very easily. So, that is the main flaw of these multi-period models. Now, coming to the conclusion, we find that for every business, proper management of the inventory system is very, very important, because if the inventory is not managed in the proper manner, what will happen is the business may go into a phase of loss. But if the inventory is managed in a proper way, then definitely the business will flourish. So various assumptions have also been taken into consideration for each model, and they are linked with some sort of advantages on one hand and disadvantages on the other hand. So that's all from my side for inventory models. Thank you so much. If anybody has any questions, ask.
Any questions, audience? Any questions? Thank you, Dr. Anu Sehal ma'am, for taking time from your busy schedule and delivering such an engaging presentation with us today.
Thank you so much. It was a pleasure being a part of this wonderful conference. Thank you.
So this marks the end of day 1 for invited talks and keynote lectures. Thank you everyone for your gracious presence, and you all can move to the halls where technical presentations are running in parallel.